Okay, now we're going to write a sine and cosine equation for this curve given here. So the first thing we want to do is to kind of first have a plan of attacks, right? So we're going to write let's start with the sine version. And we need the C value, which is the vertical shift or the midline. We need A, and then sine of B, X, and then a phase shift D if there is one. After we write the sine equation, then we'll write the cosine equation. So the first thing I like to do is find the midline. The midline goes through 2 in this case. So you just kind of look at the curve, and it's the line that cuts the line in half. There's a maximum and a minimum value. It's right in between those two. So this minimum is down at 1, the maximum is at 3. So the reason this is handy is because you can see the midline, and that is C. That's how far it's shifted up. So C is equal to 2. It also will help you find your amplitude. Your amplitude is the distance from the midline to the max, or the midline to the min. So your amplitude is 1, which makes A1. Okay, the next thing we need is B. So B is equal to 2 pi over the period of the sine curve. So 2 pi is from the period of the parent function sine x, and then whatever kind of shift we have or transformation we have from that. So here I'm going to start on the y-axis, and I'm on a minimum, so I'm just going to go all the way down, up and back down. Get those KU colors out of here. We don't like those. We'll go up and then back down, and that's 1 full cycle, and that took us a distance of 2. So that means my period is 2, which is not my B value, but B is 2 pi over P. Whoops, and P is 2. Let's go ahead and fill that in. And so B is equal to pi. Okay, so I know C, I know A, and I know B. The good news is these are the same for sine and cosine every time. So let's write the sine equation. Y is equal to 2 plus sine of B was pi. And then we're going to actually write 2 versions of this. So the first version, let's see if we can get through that crash there. The first version, we will shift over to the right. So for sine, we want to pick a spot on the curve where it intersects the axis of the wave, or the midline, and goes up. So that's one right here. We could also shift over here. These are all options for sine. And so we got to figure out what this is. So if this is 2, then half of it is 1, then this would be 1/2. This would be 3/2 or 1.5. So if I shift from here over to the right 1.5, then it looks like a sine curve. Sorry, not 1.5, just 1/2. And so my shift is going to be to the right, so I'm going to go minus and then 1/2. And that is my sine curve. Okay, for my cosine curve, everything's going to look the same except for that phase shift. So let's do 2 versions of cosine. So for cosine, we want to count over to a maximum. So we could go right or left to this maximum. Let's go left just to switch it up a little bit. So if I'm here, I'm going to go left this way. And if I go left, then I'm going to have a phase shift that is +1. Okay, now you may say, well, there's something else I could do, because this looks a lot like a cosine curve. It's just reflected. It's starting at a minimum instead of maximum. And if you see that, then you could just make the curve negative cosine, which is very smart if you see that, pi x. So either one of these will work for cosine. And as a matter of fact, there are an infinite number of solutions that will work for these problems, because I could shift left or right an infinite number of times. So there are a lot of different ways you can write the curves of these functions, as they are periodic and they repeat forever.